Thank you. Thank you for the invitation, and pleasure to be here. A lot of young people waiting to see it. I got a small little glitch here. I picked the wrong memory stick, but I'll get it in a few minutes from the car. So meanwhile, while it's on.
I can bring it.
Which one?
If you want. Until you get the one, I can take it.
No, it's okay. I'll start. Let it come. Anyway, so it's a story that I have to tell. We have to come back from the edge of the universe that Dr. Ajit took us to something closer. And so what I was going to talk about is about the planetary exploration program of ISRO. As you know, particularly the questions that Dr. Agarwal asked about the possibility of human existence elsewhere. In the current realm of astronomy, in the last, since 1995 or so, there have been discoveries of planets outside the solar system. Astronomy is, so the area of exoplanet research is a very strongly emerging area. So when you want to do exoplanet research, where you're looking at planets around other stars, it's very important to understand our solar system very well. So the study of the solar system has been a long process at hand, and today with the technology of space, we are now able to actually reach out and grab this. Just a minute. Hello. Oh, nice. Okay, thank you. Oh, that was super fast.
Faster than gravitational waves.
Yeah. It has some mass. Apologies for that. So while that's coming up, so we have been exploring the nearby universe as well, the solar system, with ISRO's capability. And so we had this first mission to the moon, Chandrayaan-1, in 2008. It was a short mission. By 2009, we had to terminate the mission. But in the meantime, we were able to actually see very useful, interesting sciences that connect to the moon, its origin and its evolution. So the objective of the most recent mission, the Chandrayaan-2, was to have a complete mission that actually not only looks at the surface of the moon using an orbiter, but also we were planning to have a lander. It lands in an area that is sort of unique because you're looking at, there have been past missions which have landed, where humans have landed in the equatorial part of the moon. And now we wanted to look at the areas that are the polar region because of an indication from the first mission that suggested that there is trace elements of water, and water is a very important thing on the moon, and that these water could really largely concentrated near the poles. And the reason for that is moon, unlike Earth, is not tilted about the plane of the solar system, the ecliptic. So moon is nearly or vertical to the plane, which then means there are regions at the poles of the moon where sunlight doesn't directly fall. So if you have a cavity or a crater, that crater would never have seen sunlight in the whole life of the existence of the moon, which is about 4.6 billion years. So that's the age of the solar system, that's the age of the sun. So there is a possibility that in these very cold regions, there is no sunlight has ever fallen in it, and which then means if there is water in the early solar system, and we believe water was there in the early nebula from which the solar system actually formed, some of that water could be stored in this region, in these trapped areas, and hence that is a very important finding in terms of being from a primordial water perspective, very important thing for us to know. The second thing, of course, is humans are not of the type that would like to explore. Once we have a chance to go somewhere, we also do. When Columbus and others traveled across the seas in the 1500s, it was really not because it was a pleasure to go. Most of them never returned. So it's very, very adventurous thing, but it really changed the way humans saw the universe, the world as much. And today, by having a chance to go beyond the Earth, we really would like to explore it. And so for that exploration, the solar system will demand, someone has a password.
Don't run.
All right. So this the availability of water is very important for continued exploration, because water has many valuable elements. One, water is required for any human existence, survival for the long run. Water, if you break it into hydrogen and oxygen, provides oxygen for breathing. You don't really want to carry all this oxygen with you all the time. Hydrogen can be used as a fuel cell for power. So search and discovery and access to water on the moon is a very important component in terms of exploring beyond. And one of the nearest things that we'd like to go to is Mars, where there is a possibility of a human presence in the very, very long run. The deep gravity of Earth, which drives an escape velocity of about 11 kilometers per second, really means every gram that you take up from below is going to be very expensive. So you really want to take the least amount of material from Earth, but utilize that from a low gravity object like the moon, and then build from there, and then move on to other parts of the solar system that we really like to do. So that sort of argues why we would like to go to the moon, and why you're spending all this money, time, and energy trying to do these things that are, sometimes people ask you, why are we doing this? So just to give a quick summary of the moon itself, it's more than 4 billion years old. I mean, by dating these rocks, you can actually find the age. Up to 4.2 billion years you're able to see, and then the other researchers believe it's almost as old as the solar system of the sun at 4.6 billion years old. It says the gravity is very small, but it's still there. It has a synchronous rotation, which is very important, because it's the same phase of moon is what we see all the time. As Earth moves, the moon is also moving alongside it. So we have a side that is called the near side. It faces us. There's a far side. The far side is not easy to do. So tomorrow for you to land on the far side is difficult, because you've got to communicate with Earth. And the Chinese have managed to do it. And to do that, what you have to do is you build another communication post in a point that is beyond moon, far enough such that you can actually see it from an angle from Earth. So it's what is called the Lagrange point 2 of the Earth-Moon system. And Lagrange point 2 falls on the other side of the moon. So the Chinese have actually established a satellite that goes around the Lagrange point 2 of the Earth-Moon system, and so when you land on the far side, you then communicate to that satellite, and the satellite then transmits back to Earth. So the direct link is available only through such a system. So that's all coming because of this synchronous rotation, which happens to any binary thing that is actually over a period of time, finally settles into a synchronous rotation system. A typical lunar day, because of this, is about 14 Earth days, because 27.3 days for it to go around, so half of the time you're actually seeing a lunar day. So when we designed this mission, we want to actually have something on the ground, and that system requires power. Power comes from only the sun. We didn't carry radioactive plutonium with us to really provide heat and hence keep it alive, or a nuclear reactor. That is all from solar energy, and which means you need to land in a place where there is sunlight. And the sunlight will last only for 14 days, and so you need to land early morning of the moon location, and then make sure you last those 14 days, do whatever experiments you want to do, and then hopefully, we never planned for it. If we were to land successfully, we would have said, we'll hope and see if we can survive the 14 days of intense cold that comes when there's no sunlight falling at that location. And so, for various unfortunate reasons, we didn't manage to do it, but that was the overall program that we had in that. It was also believed that, there's no water on the moon. It was bone dry, and that has come from these Apollo samples from when the Apollo astronauts went there. They would bring back samples of soil, rocks, and these have been studied in a very interesting manner. There is soil and rock samples from the 1969 mission, the first mission itself, that are now kept archived in a place, unopened, untouched, and preserved, because it was felt that there will be years from now, you'll have capacity to look at the same object with much more precise instruments. And today, very slowly, like a trickle is being handed out. Last year, there was a call, international call for people to ask for, if we'll give you a sample, if we give you a good idea as to what you want to do with this soil sample, and so on. So in the course of the last 30 years or 40 years, they've studied these things, and they found that actually if you look very carefully at some of these glassy molecular rock pieces, you can actually see presence of water at some ridiculous levels, at parts per million level, as you go to the center of these glassy things, which suggests water has been trapped inside these things. So there were some hints of these things, but the first mission to the moon, and there were some hints before that, but our Chandrayaan-1 mission actually carried a spectrometer which would actually look for signatures of water, and you actually saw water largely present at the surface, in a very thin layer of the surface, and using radar, you can actually look for water below the surface of the poles, and there seems to be larger reservoirs of water below the surface of the form, and derived from the backscattering of radar from the orbit. So that is the general thinking. So bone is no longer bone dry. It actually is there is clear possibility of water. Check this there. All right. And then largely when you look at the moon today, you will see dark patches and bright areas. So these bright areas are called highlands, and actually older, and mare, darker regions are places where lava-like material at some point filled in to really create flat terrains, and which are the regions where most of the previous Apollo landings have actually been. Don't worry, I'll use this. So just to quickly get a look at this, what the current thinking of how did the moon originate, there is a favorite theory that says it's primarily from the giant impact model, where you actually have a large body, maybe the body of the size of Mars, in the early solar system. Remember, the early solar system was a very violent place. You know, this gas cloud from which the sun was formed, and the remaining gas cloud had to gravitationally interact and form clumps of matter, which would then form bigger and bigger objects. And so there was a lot of collisions that would happen because of this. So in this early phase, some large body would have interacted with Earth and would have blown away a good fraction of the outer surface, some of the mantle as well, maybe even some of the core, we're not very sure, and which then very quickly coalesced to form a moon that then became Earth's satellite. This is one of the favorite theories. There are simulations that show it can happen very rapidly. We do not precisely know how long